Let us look at 2014 number 4. So train A runs back and forth on an east-west section of the railroad track. Train A's velocity measures in meters per minute. Okay, is given by differential function v sub a of t, which is right over here. Now find the average acceleration. Average acceleration from the velocity is the same thing as average rate of change. So for A, what we are doing is average acceleration is simply found by v of 8 minus v of 2 over 8 minus 2. Now v of 8 is what? Negative 120 minus 100 over 6. So we get negative 220 over 6, which is 110 over 3. And meters per minute square. So that becomes our average acceleration. Now let's look at part B. Do the data in the table supports the conclusion that A prime velocity A's velocity is negative 100 meters per minute at some time from 5 to 8. So 5 to 8 is, and then in this case you can say that since, let me write it down over here, B. Since the fact that velocity is differentiable, that means it's continuous. Since v sub a of t is continuous for 5 to 8, there is v sub a sub c, I'm going to write down continually here, is equal to negative 100 by intermediate value theorem, because v sub 5 is equal to 40, while v sub a sub 8 is equal to negative 120. Alrighty, let's look at part C. At time t is equal to 2, right over here, train A's position is 300 meters east of the origin station, and then train is moving to east, so going further away. Write the expression involving the integral that gives the position of the train A at t equals 12. So t equals 12, and then use a trapezoidal sum with the 3 subintervals. So that means part C, position, let me call that as A, position S of 12 can be found by S of 2, which was at 300, plus 0 through 12 of v sub a sub t dt. That would be the expression. Now, which is equal to 300, because originally this value was 300, plus 0 through 12 v sub a sub t dt. Now, they want you to evaluate this one using the trapezoidal sum. 0 through 12 v sub a sub t dt can be approximated by, now it will be 1/2 base times base 1 plus base 2 times height. So what we end up getting is 1/2 is all the way in the front. It's going to be 0 plus 100 times 2. Second one is 140 and then 3. 100 plus 30 100 plus 40 rather, times 3. Oh, actually, it started from 2, so actually I have to make one small correction. All these bottom values shouldn't be 0, but it should be 2, which actually makes the change here as well. The first will be gone. All right. So what I'm going to do is I'm going to move this one to the front, and then initial values were 2. And this one is 2 as well, not the 0. So first trapezoid is this, second is this one, third one is this. So we just finished the first one. Second one is 40 plus negative 120 times 3, because 5 through 8. The next one is plus negative 120 minus 150, and then we get what? 4. That's essentially what we end up getting. Now, so then this one is about 140. This one is negative 80. So we get 60 times 3 becomes negative 180 here. And then this is 270. 270 times 7 is about this is positive, rather. Positive 180, and then this one is 1080, but negative. So when you combine them together, we get negative 900, half of the negative 450. So then our final value would have been 300 minus 450, which becomes 150 with the negative. So therefore, they want you to explain 150 meters west, because if east was positive, then negative means west of the station. All right, let's look at part D here. Second train, train B, travels north from the origin station at time t. Velocity of the train is given by this way, and when time t is equal to 2, train is 400 meters north of the station. And when t was equal to 2, I believe that the train was 300 from here. Then I smell 3, 4, 5 triangle here somehow. Find the rate in meters per minute, and at which the distance between train A and then train B is changing at time t is equal to 2. So then I can even draw a simple picture here. So when t is equal to 2, train A is going out this way, where it's 300, and train B is going this way, and that's 400, and we're looking for the distance. So I can say that S sub A squared plus S of B squared is equal to distance squared. But when you take the derivative, 2s of A times velocity of A, derivative of position being velocity, plus 2s of B times velocity of B is equal to 2d and then d prime. Now, then 2's cancel away. So position for A was 300. Velocity for A was, at the time, 100. Now, second one is plus, it was 400 times velocity at, this one is equal to 2, then it becomes negative 125, and then, so we get 20. I mean, negative 125, and then 120. Oh, so 2 squared becomes 4. I got mixed up. So 4, so we get positive 125 is equal to distance between the to be 500 times d prime. Then in this case, I can divide all of them by hundreds. So we get 300, and then this is 500, so we get total 800 over 5 is equal to d prime, which is equal to 160 meters per minute. Now, so therefore, find the rate. So it is, the rate is 160 meters per minute increasing. All right, with that one, I'm going to close up. I'll see you later. Bye.